Okay, so today is the day before a test, and I normally don't record the test, the day of the test, sorry. We don't normally record that, but today I'm going to be including something, two things. Number one, I wanted to do one practice problem recorded, and then I also want to do the lab, the drone lab. I want to tell you how to do it. Now, I know some of you probably have already, your worksheets like crumpled up in your backpack somewhere, but you at least may remember that we went outside, flew a drone around, and we took some data on how fast the thing went. And all I'm going to ask you to do is change that from feet per second into miles per hour. I'm going to show you how to do that. Okay, so one thing at a time. So this 7i squared I squared I squared I minus 6i squared I squared I squared. I just made this into a whole bunch of I squareds. Why? Because I squareds are easy. They're what? They're negative 1. So really this just becomes a whole bunch of negative 1s. There's how many? 3 negative 1s, which makes that a negative 7i. Raise your hand if you had that part right. Awesome. And then this is 3 negatives also, but there's also a negative on the 6. You got to be careful with that. There's a total of 4 negatives. That makes this plus 6. And if you really want to be extra picky, the 6 should be in front. 6 minus 7i. I won't mark wrong for that on this test because I check with my colleagues and they don't seem to care if it's backwards or forwards. I would really like to take off 2% or something tiny, but I think I'm just going to give credit for it. The whole number should have been first. How many of you actually put the whole number first, or the real number first? Okay, good. Okay. Any other last questions? All right, then, this is the part where I do the drone with you. So I strongly recommend that you write this down because you'll actually be doing your drone assignment, which is just to change its speeds from miles per hour. Sorry, from feet per second into miles per hour. All right, so when we were outside, do you remember how we had this blue line and there was another blue line and I flew the drone? And I had its little quadcopter thing going here. And I flew my drone like from here, like it started, and then I flew it across this line. And do you remember how many paces it was between the two lines? 10 paces, which would mean how many feet? How many feet? 30 feet. And it did it in, do you remember how long it took from a start, like from a standing start? All right. I had a... So what did we agree to as a class on that one? 2.6. All right, so 2.6. So if this took 2.6, oh, not part of the drone, the whole drone, okay, it flew this way, and it took 2.6 seconds to go 30 feet. Write this down, please. 30 feet over 2.6 seconds. If it was only as easy as just dividing those two numbers, well, it kind of is, but that's in feet per second. If you haven't already written that down, write it down, because you need to show your work. The work is what this is all about. The final answer is useless if you don't have the work shown. Okay, got that so far? Now, why do you think I am multiplying this by 5,280 feet? But what's that equal to? 1 mile. Do you notice that I put it in a factor? These are called conversion factors. Has anybody ever used them before? In science, okay. And in science, I bet you they call it dimensional analysis. What do they call it? Okay, all right. I can work. Dimensional analysis is one of the ones I've heard. You've heard that too? Okay. All right. Then, this is really important. The feet just canceled. So what units are left? Miles per second. Do you think it went a lot of miles in a second? No. There are things that do. This is insane to even think about. There are things that travel way more than 1 mile in a second. That long, they've gone a mile. hard to even fathom something going that fast. But there are things that go way faster than that, speed of light, for example. But back to, this is miles per second, and when you divide it, you'd have a really small number of miles per second. It would be a decimal. Why is it so small? Because it's 30 times 1 divided by 5,280 times 2.6. All right, so am I done yet then? No, it's in miles per second. Nobody uses that. What do you think people use a lot? Miles per hour, and that's your goal, is to keep multiplying this by stuff until it's miles per hour. You just keep multiplying it by stuff. So, well, it's already got the miles. Do you think I want them to cancel? No, it's already got miles in it. It needs hours in it. How do I get seconds to cancel? So I'll have hours. 60 seconds in 1 minute. And I know some of you are like, but that's minutes. I didn't want minutes. I wanted hours. If you wanted to say there was 3,600 seconds in an hour, that would have been okay. Or you can just keep going. Seconds are canceled. Keep writing this down. We're doing your lab right now. Now I'm not going to finish it. Okay, fine. I'll finish this one. But then you're going to have to do the other one, which is, this was the one where it had a standing start. Do you remember when a lot faster when it had a running start? Okay, so you'll have to do that one. But it's the same exact conversion factor, so it shouldn't be that hard. All right, so help me. We'll just help the whole class here to finish this one off. Right now I got miles per minute. That's not miles per hour. So 60 minutes in 1 hour. How do I know where to put the minutes? Because I wanted them to cancel, and that means one's on the bottom and one's on the top. And now is my answer in miles per hour? Yeah, they're the only units left. Miles, hours. Multiply all the way across the top, multiply all the way across the bottom, and you got miles per hour. All right. Now, I don't know what that is. You'll have to use a calculator, and you'll have some big number on the top divided by some big number on the bottom. And I'm guessing the answer probably comes out to, like, 5 miles an hour or 8 miles an hour or something like that. Because it wasn't going really fast. But then on the one that was going faster, let's all agree on the time it was. It did 30 feet in 1.3 seconds. Well, it's not going to be too tough to tell that it went a lot faster, right? So it shouldn't be too tough to do. Then the third question on the drone sheet asks about, it may not be actually number 3, but there is a question about vertical speed. I never did that with you because I didn't feel like we had the time, and you couldn't actually get the data because I had to look at my iPad screen and find out how many feet it went vertically in how many seconds. And I don't know, to me it was just not as cool as going and doing the thing at a running start, because you could do the timing yourself on that. So you may skip the part of the drone lab that says vertical speed because you don't have data. Then what's the very last thing? Rotational speed. What am I talking about? That is a propeller, if you can't tell. And a little dot on the outside of the propeller would have been rotating around in a circle like this at 5,000 RPMs. Rotations per 1 minute. That's what RPM actually means. Write that down. 5,000 rotations per minute. You may want to do this in the backside or something, because this is completely separate. This is about rotational speed. Now write it as a fraction like this, because we're going to start multiplying it by fractions until it gets to miles per hour. Well, minutes, you're used to that one, but rotations? Hint, you want a rotation to be, what is one rotation? Think about it. In the context of a circle. Yes, it's 360 degrees, but that would give me degrees per something. I don't want degrees per. Circumference is a rotation. One rotation is one circumference, and a circumference is pi r squared. No, it's not. What's the circumference? A lot of kids forget this one. Everybody knows the area 1 pi r squared. Everybody knows that. But what's the circumference? Pi d, very good. Okay, pi times diameter. It'd be great if we knew the diameter, but we do. Do you remember me telling you how big the radius was? The radius was 4.5 inches. Put that away. If the radius is 4.5 inches, what's the diameter? 9. 9 what? Yeah, it's 9 pi what? Inches. Now I have inches per minute. Do you think you could change that to miles per hour? Sure could. Get inches out of there. 12 inches is a foot. And how many of you knew the 5280 number? If I say 5280, she would say 5280. Again? You get what just happened there? 5 tomato is the same as 5280. So if you just remember 5 tomatoes, you've got 5,280 feet in a mile. Now, you may not think you'll ever need that number again. You're wrong. In pre-calc, it's on one of your tests where you just expected to know it. We just expect you to know there's 5,280 feet in a mile, and a lot of kids don't. We'll remind you again next year, but 5280, 5 tomato. Remember it however you want, okay? Memorize 5,280. And you'll need that in this calculation. It'll go somewhere. First thing I'd do is cancel off the inches. And hopefully you know some fact about inches. If you don't, I guess you're stuck and you're going to get it wrong. But I bet you'll figure it out. Last thought, you can talk to other people about this. It's okay if you get lost and you've got a smart friend. You can't just copy theirs. You can ask them, how do you do this? And they'll be like, oh, you just got to change here from inches to feet. And so you're going to go 12 inches, 1 foot, and, you know, get some help from them if you want. All right. Last thing, want to just kind of get you back in this test mode. Oh, and by the way, that worksheet is not due Monday. If I were you, while it's fresh in your mind here, I would get the ones that you can do done. And maybe you can do everything from what I just said. Maybe you're ready. You need to do the whole thing. But at a minimum, get as far until you're stuck on the worksheet. Then you'll be able to ask us questions in class on Monday. It's not due Monday, but it'll probably be due like Wednesday or Thursday or maybe even Friday of next week. But if I were you, let's start on your lab. Okay. First step. Dice of destiny. Give me a person. You should go on 5, 3. Row 5. Person 3. That's you. First step. Yes, square root. Square root. Absolute value of x minus 3 is 5. Dice of destiny. Who's going to do my second step? Row 1, person 3. That's you, sir. Split it. 2 equations. The first one's easy. I think you're stuck in the mode of I'm trying to get x alone. You're not trying to get x alone. You're trying to write me a nice simple equation that doesn't have absolute values in it. I'm going to help you. X minus 3 equals 5. Then the other side of the equation, which is strikingly similar to this one. X minus 3 equals what? Negative 5. Then, what's the last thing to get that solved? So x is alone. X equals 8. X equals negative 2. How could I know for sure I was right? You put them back in here. Does that work? Does 8 work? Yeah, what's cool about this is you can know you're right. Excuse me, stop talking. I need your attention. Thank you. Next, we're going to put in the negative 2, and we're going to see if that works. Negative 2 goes right here. Does it really work? Yeah, negative 2 minus 3 makes negative 5. Absolute value is 5. Yeah, it worked. Remember to check these, because especially when you move on to higher level math, sometimes this year too, we have answers that don't really work. You think you've got the answer, but if you check it, it doesn't really work. It's called an extraneous solution. These worked. All right, that's all I got for you. Time to take your test.